Okay guys, as promised, here is your video for concentration. Now, we're going to put our name at the top of our note sheet. You should have it blank in front of you, ready to copy down or just kind of review. Now, we've been talking about solubility and how we have a solution that's made up of a solute and a solvent, okay, and how Kool-Aid, for example, would have sugar as the solute and water as the solvent. But how do you tell when the strength of it or how much is in there? Well, that's what concentration tells us. Concentration is the amount of solute divided by the amount of solvent. Basically saying how much sugar do we have in this water or how much chemical do we have in this water. Okay. Now, concentration can be described two ways, as either being a dilute solution or a concentrated solution. And a dilute solution has a small amount of solute in it, whereas a concentrated solution has a lot of solute. Now, we all know we've been to a restaurant and ordered sweet tea, and some people's version of sweet is not the same as Miss Nichols. Miss Nichols likes hers as thick as syrup, okay, real sugary. It'd be very, very concentrated. Whereas some people only like a little sprinkle of sugar, okay? So something that only has the small amount of sugar would be dilute. A lot of solute, in our example of sweet tea being sugar, it would be concentrated. Now, molarity is a specific way that we measure concentration. It's abbreviated with this capital letter M, and it's the moles of solute in 1 liter of solution. Okay? So the equation is molarity is equal to moles solute divided by liters solution. Okay, now it can abbreviate it as capital M is equals to mole over L. So let's look at this practice problem. If it says what is the molarity, so molarity is my question mark, I don't know what it is, of a solution in which 10.0 moles of AgNO3 is dissolved in 500 liters of solution. Okay, so first thing, remember we use the guess method, G-U-E-S-S. The first step, G, is given. We write down the things that we're given. Well, we are given our moles and we're given our liters. What is our unknown? That's our U. Our unknown is our molarity. We do not know our molarity. E is equation. We write down our equation. We know our equation is M is equal to moles divided by liter. The first S in guess stands for substitution or plug it in. So we know that our moles are 10.0 moles AgNO3 and our liters are 500 liters. And the last S stands for solve. So we would just solve. So 10 divided by 500 is 0.02 moles per liter of silver nitrate, or you could also write it as 0.02 capital M AgNO3. Both are correct, however, you're going to see this way written most often. Okay, so if you have any more questions about that, we're going to do some more sample problems a little bit later, but make sure you're following the guess method and showing all of your work. Now, if we look at dilution, okay, what is dilution? Well, dilution is when you take a concentrated solution and you add more water to it or add more solution to it. Okay. And what this does is it changes the volume without changing the number of moles. Okay, guys, so without changing the moles, we can change the volume, and it basically allows it to spread out. And so our equation for this is going to be mcvc equals mdvd. Or you could also write it as m1v1 equals m2v2, where essentially all you need to know is that these ones go together and these ones go together. Basically, your molarity and your volume are partnered together. Okay, now what I mean by that is, well, you'll be able to see in the next problem. So our example says how much concentrated 18 molar sulfuric acid is needed to prepare 250 liters of a 6.0 molar solution. Now, in order to do this, okay, we first need to find out what we've got. We've got an M, liters is volume, and we've got another M here. So with two M's, how do we decide which one is which? Well, I always make M1 or MC the biggest one. So 18 molar is bigger than 6 molar, so I'm going to make this MC, which automatically makes this one MD. And just as a reminder, C stands for concentrated, or the strongest, which is why I picked the biggest number, and D stands for dilute, or the weakest, smallest number. And now we need to decide, okay, well, this volume, which one does it belong to? And this is where we get into our language arts sentence structure. This word of here, okay, of signifies belonging. If I say that this is the hat of Giselle, that means this is Giselle's hat, okay? Those things belong to each other. So this word of says 250 liters of 6.0 molar solution. So it means these two things belong to each other. And if they both belong to each other, then that means this is VD because that is MD. Okay, so now we've labeled all of our things. Anytime you have two molarities and a volume, you're going to be using our formula here. So we know we have MCVC equals MDVD. When we're looking at our guess method, we're using given unknown equation, which we just did, substitution, and solve. So next we need to substitute. So we need to plug our numbers in. So I know that MC is 18 molar, but I don't know what my VC is, so I'm just going to multiply it and leave that letter there. It's equal to MD, which is 6.0 molar, times VD, which is 250 liters. Now, in order to solve this problem, we're going to do a little bit of math. Okay, we're going to keep 18 molar times VC on this side, and we're going to simplify our right side. So 6.0 times 250 gives us 1,500, and we also multiplied our units, so I write them both down, moles times liter. Okay, and now in order to get VC by itself, I'm going to have to do the opposite of what's happening, which is divide by 18 molar on both sides. When I do this, my 18 molar cancels out with 18 molar, my M cancels out with my M, and it's going to give me VC is equal to 1,500 divided by 18, which is going to be 83.3 liters. And that'll be my final problem. Now, you're going to use this basic steps to help you answer the rest of the questions. One thing that you want to make sure you keep an eye out for is if they give you 200 milliliters, you're going to need to automatically convert it to liters. Now the way you do that is you take your conversion and you either divide by 1,000 or you move it 3 places to the left. So 200 milliliters would be 0.2 liters. Another thing is if they give you grams instead of moles, you'll need to convert from grams to moles using the way we've always done. Let's say they give you 45 grams of NaCl, but we need moles. We would take our 45 grams NaCl, we would set it equal to X number of moles. We would bring our grams down to the bottom. And remember, anytime we see grams, that means we look at our periodic table and we calculate our molar mass. So our molar mass of NaCl would be NaCl, we have one of each. The atomic mass for sodium on your periodic table is 22.99 and chlorine is 35.45. When we multiply them out, we get 22.99, 35.45, and when you add them together, you get 55.44 grams. And that gets plugged in right here. I'm going to draw a line here so we can keep this work separate. And then anytime you have moles, you're going to write mole on the bottom, and it's always multiplied by 1. So when we cross multiply, we're going to have 1 times 45 is 45 grams NaCl times mole divided by 55.44 grams NaCl is equal to X mole. Now normally we would have cross multiplied this way as well. However, we do not have to do that because we know that our X is already by itself, so we can leave it alone. So we would know that our X moles is 45 divided by 55.4, which is 0.81 moles. So you can use that same methodology to convert your grams to moles before actually starting on your problem. So make sure you work the rest of the practice problems on here, making sure to focus on how we do this, and ask me if you have any questions.